Okay, this is lesson 55 for 7th grade, and today we're going to talk about some average and rate problems with multiple steps. Basically, the way that we're going to think about it today is we're going to take a look at mostly average and kind of think about it backwards. So it's going to be a little weird. Let me grab my calculator quick. It's going to be a little bit different than the way we think about average. We're going to think about it a little backwards. So let's see what we're talking about here. With this example. So we've got 4 examples that we're going to go over today. And this is the first one. Okay. So it says the average of 3 numbers is 17. What is their sum? Okay. So normally when we think about average, we would add up, in this case we would add up 3 numbers and then divide it by 3 to get our average. So it gives us the average. This is basically saying x plus y plus z divided by 3 equals 17. So we don't know what these 3 numbers are, but we do know that when we add them all together and divide them by 3, we get 17. So what we really need to do is figure out what number, when we divide it by 3, is 17. So we don't need to know the individual numbers, but we do know that once we divide them by 3, when added together, we get 17 for an average. So let's think about this. If we add 17 3 times, we should get a number that is divisible by 3 that will give us 17, right? Because this is basically 17 times 3, and then if we were to take that answer and divide it by 3, we should get 17 again. Okay? Basically what the average means is taking all these 3 and equalizing them. So really what it means is 17 plus 17 plus 17, and then that's where we get the 17 from. Okay? Sounds kind of weird, I know, but if we add all 3 17s up, we should get a number divisible by 3 that gives us an answer of 17. So let's just do 17 times 3. 3 times 7, 21. 3 times 2, 1 is 3, plus 2, 51. Okay? So the sum is 51. And if we divide by 51 by 3, we get 17. Okay? So we're not concerned about, again, we're not concerned about what numbers we're adding up, but we do know that they add to 51. They have to, because when they're divided by 3, we get 17 for an answer. Alright? One other way we could have looked at this, probably with the ratios that we've been dealing with, is that let's call this our sum. X is our sum. When we divide our sum by 3, we get 17 over 1. So in order to solve for that sum, we do the cross multiply divide. 3 times 17 is 51 divided by 1. Alright? That's another way we could have looked at it. I know it's a little funky. And it gets a little more funky after this. Okay, so this one takes it even a step further. The average of 4 numbers is 25. Alright, so the average of 4 numbers is 25. If 3 of the numbers are 16, 26, and 30, what is the 4th number? Okay, so now they're asking us specifically what the 4th number is going to be. Alright, well let's think about this again. The average of 4 numbers, so we need a sum that when we divide it by 4, because there are 4 numbers, we get 25 for an answer, or 25 over 1. So basically what this is telling me is that when these numbers are added together, our sum should be 4 times 25 divided by 1, or just 4 times 25, which is 100. So our sum equals 100, because 100 divided by 4 gives us 25. Alright, and we know the other 3 numbers, so let's add those up. 16 plus 26 plus 30. 6 plus 6 is 12, carry the 1, 2, 4, let's see, 1, 2, 3, 4, 7. Okay. 72. So then, to figure out our fourth number, this isn't the fourth number, because we need them all to add up to 100. 100 minus 72. And that should give us our fourth number. Scribble small, squeeze that out. So we got 10 minus 2, 8, 9 minus 7, 2. So we'd be looking at 28 would be our fourth number. And if we do 28 plus 16 plus 26 plus 30, we would get 100. 100 divided by 4 gives us 25. And there we go. It's interesting stuff, but it's kind of fun to think backwards a little bit. Okay. Here's our next one. Kind of similar to the one we just did. After 4 years, the average number of students participating in after-school sports was 89. Okay? So there's our average. Alright? How many students must participate in the 5th year to bring the average up to 90? Okay? So, after 4 years, the average is 89. So that says we need a sum. That when we divide it by 4, we get 89. Or 89 over 1. Okay? So 4 times 89. That's 4 times 90, 360 minus 4. So 356, I believe. Okay? So that's 4 times 89. Alright? So that's our sum there. What we need then is we're going to add on a 5th year. So we need the average to be 90. So we're going to look at another scenario. So this is 4 years. And then we need 5 years. Okay. So after 5 years, now we have a new sum. That one divided by 5, we get 90. Okay? So our sum here would be 5 times 90 when we cross multiply. So y equals 5 times 90, which equals 450. Okay? So we look at the difference here then. So we need 450 minus 356. Okay, so basically what this is saying, in our 5th year, we need to go from this total number to this one. So our 5th group, or our 5th year of students, needs to be 450 minus 356. And subtract those. So 94 students. So if we add 94 to this number, that's where we get 450, and 450 divided by 5 gives us that 90, which was the average they were looking to get to. Alright, that one was probably the most involved. And this last one here, I'm not going to go through, but I will tell you how to solve it. It's a different type of problem, but it talks about figuring out what's the better buy. Okay, so it says he's buying refreshments for the next math club meeting. There's a brand A, cranberry juice, so we'll say A, and then there's a brand B. Okay, it says brand A is on sale at $3.20 for a 64-ounce bottle. Okay, and then we've got brand B at $1.19 for a 17-ounce bottle. So really we want to figure out price per ounce here. So we want price per ounce. So for brand A, it's $3.20 for a 64-ounce. And here is $1.19 for a 17 ounce. Okay? If we solve these proportions, we'll call this A and B. So really, if we solve 3.20 over 64 equals 1 over A, and if we solve $1.19 over 17 equals 1 ounce for B. If we go ahead and solve for A and B, we should be able to figure out what the better buy is, okay? And we would go from there. Just to put the answer out there, we should get, the better buy should be, what did they say? The better buy should be, it says brand A is better. Does that make sense? So it looks like we would get so we get 5 cents here, and we get 7 cents here per ounce. So 5 cents per ounce is better than 7 cents per ounce if we went through and solved those. It'd just be a cross multiply divide problem. All right, we'll be going over this for a couple days because it's kind of a new topic, and we'll go through a bunch more of it.